Stan Gibilisco here, proprietor and operator of amateur radio station W1GV at your service to talk about a peculiarity in antennas and transmission lines that you can occasionally take advantage of, and that is the fact that at half wavelength intervals from the load, normally an antenna, half electrical wavelengths, that means you have to take the velocity factor of the transmission line into account. At intervals of a half wavelength, whatever impedance your antenna has will be duplicated or repeated exactly. It doesn't matter what the characteristic impedance of the transmission line is. It can be anything. It doesn't matter what the impedance of the antenna is. It can be anything. It doesn't really matter whether you use a coaxial line, a television ribbon, window line, ladder line, any kind of line. You don't have to have a 1-to-1 standing wave ratio here. Nothing. The only thing that you do need to be sure of is that you take the velocity factor of the feed line into account, V. Normally V can range somewhere between, it can be as low as about 66% in the case of coaxial line with solid polyethylene dielectric, or as great as 92% or maybe even 95% for ladder line or open wire line with spacers at infrequent intervals and an air dielectric. But you need to know that velocity factor in order to take advantage of this so that you can calculate exactly what these half wavelengths intervals are. And once you know that velocity factor, once you know that V, then 1/2 wavelength equals 492 times V divided by the frequency in megahertz. And this is a half wavelength in feet. You can use that formula then to calculate these intervals from the antenna to this point, from this point to this point, from this point to this point. So it doesn't matter what your antenna impedance is. Now suppose then, for example, that you have, let's just say a dipole antenna. Open dipole antenna in free space has a characteristic impedance of about 73 ohms. Not characteristic impedance, pardon me, a purely resistive impedance. That means no reactance. So you're going to see that same 73 ohms, no reactance, here, here, and here. Whether you use a 75 ohm line, a 50 ohm line, a 300 ohm line, a 450 ohm line, it doesn't make any difference as long as you know what this velocity factor is. So you can in fact use, for example, an open wire line of any characteristic impedance you might want. And if your radio is, say, exactly 2 wavelengths away from your antenna, exactly 2 wavelengths, all you need to do with this balanced line is use a balun, a 1-to-1 balun, and you will see a 73 ohm pure resistance with an unbalanced load for your radio. Most radios want about 50 ohms but are happy with any mismatch up to 2-to-1. So that this would give you a standing wave ratio of about 1.4-to-1. You'd have practically no loss. And in that way, rather than going to all of that trouble of using a coaxial cable, all of that expense, I should say, you could use, say, window line or ladder line, as long as you make that 2 electrical wavelengths long or any whole number multiple of 1/2 electrical wavelength. You can get away with this And with open wire or window line, the SWR can be pretty much disregarded. You don't even have to think about it. Just a little tip, just something that you might take advantage of in certain situations in your amateur radio life. Stan Gibilisco, W1GV, saying 73, and so long for now.